Hi, this is Saxena from Just Tutors. Today in this video we are going to learn about human eye and this colorful world. Objectives of today's video are dispersion of white light by glass prism, atmospheric refraction, scattering of light, why the color of clear sky is blue, and color of sunlight at sunrise and sunset. Let's move ahead. So, dispersion of light by a glass prism. Basically light. Visible light known as white light. It consists of a collection of component colors. These are observed only when light passes through a triangular prism. When this white light is separated into its component colors, which are red, orange, yellow, green, blue, and violet, it is known as dispersion, or we can say this phenomenon is known as dispersion of light. We can remember this order of scattering of light or components of light in this way. We call it Vibgyor. You can also see this in further slides. Vibgyor. V is for violet, indigo, blue, green, yellow, orange, red, and it is from bottom to top in this way. You can see violet, indigo, blue, green, yellow, orange, and red. On the next slide, we will see the image clearly. Dispersion of white light has some properties. The sequence formed used as acronym Vibgyor, which we have discussed on last slide. Violet, indigo, it's blue, violet, indigo, blue, green, yellow, orange, and red. Different colors of light bend through different angles in respect to the incident ray as they pass through prism. Red light bends the least and violet light bends the most. As you can see here, red line has less bend and violet light bends most. Next is recombination of the spectrum. As you can see on the last slide, when sunlight or any white light passes through a prism, it is scattered into 7 different colors or components of white light. If I put another prism in opposite way, or like in this picture, just vertically opposite to the prism, all these 7 lights again combine to the single one light. This is white light. It allows all the colors of a spectrum to pass through the second prism. A beam of white light is found emerging from the other side of the second prism. This observation gave Newton the idea that the sunlight is made up of 7 colors, and any light that gives a spectrum similar to that of sunlight is often referred to as white light. Now, atmospheric refraction. It is the deviation of light or electromagnetic wave from a straight line as passes through the atmosphere due to variation in air density as function of altitude. This refraction is due to velocity of light through air decreasing with increased density. For example, advanced sunrise, delayed sunset, and twinkling of stars. Moving forward, we will see how how stars twinkle in the sky. It is due to the atmospheric refraction of sunlight. It occurs in a medium of gradually changing refractive index. As atmosphere band starlight toward normal, the apparent position of star is slightly different from the actual position. You can see in this picture. Actually, star is here, but when we see it, it seems to be here at position. This is called apparent position of star or apparent star position. Stars appear slightly higher than the actual position when viewed near the horizon. Scattering of light. In air, part of sunlight is scattered. The small particles such as molecules, water droplets, and dust particles scatter photon the more, the shorter their wavelength is. Therefore, in scattered light, the short wavelengths predominate. The sky appears blue, while direct sunlight is somewhat yellowish or even reddish when the sun is very low. You can see in these pictures how it happens. Now, the question, why is the color of the clear sky is blue? The blue color of the sky is due to Rayleigh scattering. As light moves through atmosphere, most of longer wavelengths passes straight through. The absorbed light is radiated in different directions and it gets scattered all around the sky. Whichever direction you look, some of this scattered blue light reaches you. We see the blue light from everywhere overhead. The sky looks blue. This is the only reason. Colors of the sunlight at sunrise and sunset. Light from the sun consists of three kinds of radiations, which are ultraviolet rays, visible light, and infrared rays. At sunrise, the earth is rotating towards the sun. Similarly, during sunset, the earth is rotating away from the sun. As sun begins to set, the light must travel farther through atmosphere before it reaches. More of the light is reflected and scattered. Light from sun near horizon passes through thicker layers of air and larger distance, so it appears red. At moon, sun appears at noon, sun appears white as only a little of blue and violet colors are scattered. Visible light rays are white and consist of 7 colors. They are most commonly known as Vivcure, which we have discussed. Again, I am going to repeat them: violet, indigo, blue, green, yellow, orange, red. Most of these colors like green and violet get scattered before the light reaches the earth. Since red is scattered the least, it is the color that we see as it reaches us. Then we have practice time. Pause this video, try these questions using your facts or knowledge which we have learned in this video, and then check your answers on the next slide. Here are your answers. That's all for this video. For more videos, keep logging in justtutors.com. Thank you.